For as long as we have looked up, we have dreamed. We gazed at the pinpricks of light in the vast dark canvas of the night sky. One of them glowed with a special reddish hue. We named it Mars, after a god of war. But our dreams were of peace, of exploration, of a second home for humanity among the stars. This tiny red dot captured our imagination. It became a symbol of what could be, a challenge whispered across the solar system. Could we, a species born on the blue marble of Earth, ever walk upon that distant, rusty soil? The question is no longer just a dream, it is a plan. The journey begins not in space, but right here on Earth. It starts with a vision and incredible engineering. To escape our planet's strong gravity, we need immense power. We need rockets unlike any built before, giants of metal and fire capable of pushing a precious cargo of humans and supplies toward another world. These are our modern-day sailing ships for the cosmic ocean. Launching such a vessel is a spectacle of controlled violence. It's a testament to our understanding of physics, a roaring declaration that we are ready to leave the cradle and take our first steps into the solar system. But a rocket is just a vehicle. The true pioneers are the astronauts inside. Their journey begins years before launch. They train relentlessly, preparing their bodies and minds for an environment that is completely alien. They learn to be doctors, engineers, geologists, and pilots all at once. They spend countless hours in simulators, practicing every possible scenario, from a smooth landing to a critical failure. They submerge themselves in underwater labs to mimic the feeling of weightlessness. This training forges them into a team, a small family ready to face the immense loneliness and danger of the void together. The moment of launch is the culmination of all this effort. It is the point of no return. As the engines ignite, they unleash a force that shakes the very ground. The rocket slowly, then rapidly, climbs into the sky, a brilliant spear of light piercing the blue atmosphere. For the astronauts strapped inside, it is a bone-rattling ride, a powerful push that pins them to their seats. They are riding a controlled explosion, a magnificent display of human ingenuity. They are leaving everything they have ever known behind, propelled by a dream that is shared by billions of people watching from below. They are on their way to Mars. Once free from Earth's embrace, the roar of the engines fades to silence. The mission enters a new phase, a long, quiet coast through the emptiness of space. This journey will last for many months, a silent ballet between two planets. During this time, the astronauts live in a state of constant freefall or zero gravity. While it may look like fun, it takes a toll on the human body. Without the constant pull of gravity, muscles begin to weaken and bones lose their density. Astronauts must exercise for hours every single day, using special resistance machines just to stay healthy and strong for their arrival. The emptiness of space is not truly empty. It is filled with invisible dangers. One of the greatest threats is cosmic radiation. Without Earth's protective magnetic field and thick atmosphere, the spacecraft is bombarded by high-energy particles streaming from the sun and distant supernovas. This radiation can damage human cells and increase the risk of long-term health problems. The ship must have specialized shielding to protect its crew, but some exposure is unavoidable. The astronauts become cosmic sailors, navigating not just through space, but through an invisible storm of galactic rays. Beyond the physical challenges, there is the immense psychological strain. The crew lives in a small, confined space, millions of miles from home. Earth shrinks to a small blue dot in the window, a constant reminder of their isolation. They must rely on each other completely, resolving conflicts and supporting one another through the stress and monotony. Maintaining good mental health is just as critical as maintaining the life support systems. Regular communication with family on Earth, scheduled downtime, and a strong sense of purpose are essential tools for surviving the profound loneliness of deep space. Each day on the voyage is a careful routine of system checks, scientific experiments, and personal maintenance. The crew monitors the spacecraft's health, ensuring that every pump, wire, and computer is functioning perfectly. They might conduct experiments on how plants grow in microgravity or study the effects of space on their own bodies. This is not a passive journey. It is an active mission from the moment it begins. They are not just passengers. They are scientists and explorers, gathering knowledge even as they fly through the dark, preparing for the greatest challenge that still lies ahead, landing on Mars.
Perfect.
After months of travel, the red disk of Mars grows larger in the window, transforming from a point of light into a world. but landing on it is one of the most difficult feats in space exploration. Mars has an atmosphere, but it is very thin, about 100 times thinner than Earth's. This makes it tricky. It's thick enough to create tremendous heat from friction as the spacecraft enters at thousands of miles per hour, but it's too thin to slow the craft down enough for a safe landing with parachutes alone. This phase is often called the 7 minutes of terror for a reason. The landing sequence is a complex, automated dance where everything must go perfectly. First, a heat shield on the front of the capsule bears the brunt of the fiery entry, glowing red-hot as it plows through the thin Martian air. Once the craft has slowed down, a massive supersonic parachute deploys, yanking the capsule and further reducing its speed. But even with the parachute, the craft is still moving too fast. In the final moments, the parachute is cut away, and powerful retro rockets ignite, firing downward to carefully control the final descent and bring the lander to a gentle touchdown on the surface. The moment the lander's legs touch the ground, a new era begins. Silence. For the first time, humans are sitting on the surface of another planet. After exhaustive system checks, the historic moment arrives. The hatch opens. An astronaut, clad in a protective spacesuit, slowly descends the ladder. The first boot print is pressed into the fine red dust, a mark that will last for ages in the thin, dry air. This single step is the culmination of centuries of dreams and decades of work. It is a profound statement. We are here. Humanity is now a multi-planetary species. The first tasks are all about survival. The crew must immediately begin setting up their home, an inflatable or prefabricated habitat that can be pressurized to create a breathable atmosphere inside. They will deploy solar panels or set up a small nuclear reactor to generate the power needed for life support, science equipment, and communication with Earth. They will also deploy instruments to extract resources from the Martian environment, such as the MOXIE experiment, designed to produce oxygen from the carbon dioxide-rich atmosphere. These first steps are crucial. They are the foundation upon which a colony will be built. Surviving on Mars means living in a carefully controlled bubble. The first Martian homes, or habitats, will be pressurized modules connected by tunnels. These structures must protect the astronauts from the thin, cold atmosphere and harmful solar radiation. To expand their living space, colonists will learn to use the resources around them. Robotic systems will scoop up the Martian soil, known as regolith, and use three-dimensional printing technology to build new structures, layer by layer. This technique, called in situ resource utilization, is key. It means we don't have to ship everything from Earth, making the colony more self-sufficient. Daily life will be a structured routine governed by the needs of survival and the mission's scientific goals. Mornings might be spent tending to crops in a hydroponics bay, where plants are grown in nutrient-rich water under LED lights. This indoor farm is the colony's lifeline, providing fresh food and recycling carbon dioxide into breathable oxygen. Afternoons could be dedicated to scientific exploration, either analyzing rock samples in the lab or venturing outside in advanced rovers. Constant exercise will remain vital to counteract the effects of Mars's lower gravity, which is only about 38% of Earth's. The Martian environment is harsh and unforgiving. One of the biggest dangers is the weather, specifically the massive dust storms that can engulf the entire planet for weeks. These storms can reduce visibility to near zero and coat solar panels in a thick layer of dust, cutting off power. The colony must be designed to withstand these events, with reliable energy storage like batteries or nuclear power and robust systems to filter the fine dust from the air. Radiation shielding, perhaps by burying habitats under several feet of regolith, will be essential for long-term health and safety. As the outpost grows, it will transform into a true colony. More modules will be added, connected by underground tunnels to protect against radiation and the extreme temperatures. Advanced robots and rovers will become essential partners, performing heavy construction, mining for water ice buried underground, and conducting explorations in areas too dangerous for humans. This human-robot collaboration will accelerate the colony's growth, turning a small survival shelter into a bustling scientific research station, a small town on a new world, a beacon of human presence shining in the deep, cold expanse of space. As our Martian colonies become more established and self-sufficient, we will begin to look at the planet with even greater ambition. Our thoughts will turn to a far-off, science fiction dream terraforming. This is the process of changing a planet's environment to make it more like Earth's. It is a monumental concept, something that would take centuries or even millennia to achieve. The first steps might involve releasing greenhouse gases trapped in the Martian soil and polar ice caps to thicken the atmosphere and warm the planet. This could, in theory, eventually lead to flowing water on the surface. The dream of a green Mars is a powerful one. Imagine a future where the atmosphere is thick enough to breathe, where liquid water flows in rivers and fills ancient crater lakes. Imagine planting the first forests in the red soil, watching as the planet slowly transforms from red to blue and green. This is the ultimate expression of human ingenuity and our ability to shape worlds. While it remains a distant vision, it inspires us to push the boundaries of science and technology. It gives our journey to Mars a grander purpose, not just to visit, but to one day create a second garden for humanity. The journey to Mars is more than a technical challenge. It is a test of the human spirit. It requires courage on a scale we have rarely seen, the courage of the astronauts who risk everything to venture into the unknown. It demands cooperation on a global scale, with nations and private companies working together to achieve a common goal that is bigger than any single one of us. Exploring and settling Mars will be a story of our greatest strengths, our curiosity, our resilience, and our ability to dream of a better future and then build it piece by piece. And so we look back up at that red point of light in our night sky. It no longer seems so distant or so alien. We see it now as a destination, a future home. The path is difficult, filled with dangers we are only beginning to understand. But the call to explore is woven into our DNA. It is who we are. The question is no longer if we will go to Mars, but when. And as you gaze at the stars tonight, you might ask yourself a new question. If you had the chance, would you go? Would you join the pioneers building a new branch of human civilization on the dusty red plains of Mars?